2, the product rule. The product rule, you can identify the product rule in differentiation when you have two separate numbers being multiplied by each other. That's when you know you're doing the product rule. What you'll do for all of these questions is you'll always look in between the two brackets. So for example, question 4, you'll go in between the two brackets and you'll compare it to y equals u multiplied by v. Whichever one comes first can be u, whichever one comes second can be v. So what we're first going to say is u is x plus 3 and v is x squared minus 6x plus 8. Everybody happy thus far? Okay, next thing. There's something that's called dv dx and du dx. What that means is differentiate what u is, differentiate what v is. So du dx means differentiate as you've done before. What is the differential? What happens when you differentiate x plus 3? When you differentiate x, you get 1. Whatever number comes in front of the x is what you get. When you differentiate 3, you get 0. Du dx is the number 1. Dv dx, differentiate x squared, we get 2x. Differentiate minus 6x, minus 6, differentiate 8, 0. You now know what u is, you know what du dx is, you know what v is. What you gotta do is you go to your tables and you take down this formula. Du dx equals, u times dv dx plus v times du dx. And all you do is fill it in exactly in sequence. Okay, u is x plus 3, dv dx is 2x minus 6, plus whatever v is x squared minus 6x plus 8, du dx is 1. Let's multiply this out. Okay, x times 2x, 2x squared, x times minus 6, minus 6x, plus 6x, minus 18, and then plus x squared, minus 6x, plus 8. Now let's see what happens here. Okay, 2x squared plus x squared gives us 3x squared, minus 6x plus 6x is gone, minus 18 plus 18, oh sorry, that's a plus 8, excuse me. Sorry, minus 6x, forgot about that. And then minus 18 plus 8? Minus 10. And that's your answer. You're asked what the y dx is. Okay? You don't have, no, you just leave your answer like that. It's perfect. Okay? Anyway guys, number 6, okay? Now with number 6, first things first, split it in half. I've identified it's a product rule because there's no fractions and there's two separate entities being multiplied by each other. What I mean by separate entities is there's one bracket multiplied by another bracket. That means I'm looking at a product rule. I'll let the first one be u. U is 3x cubed minus 2x squared plus 4. I'll let v equals 2x minus 1. Now what some people asked me there was, when I differentiate, I add in d, I'm differentiating u. Now, what determines what letter is on the bottom is what u is explained in. U is explained in x's. So that means there's going to be a dx on the bottom. Now, also what this means is differentiating. So we're going to get 9x squared minus 4x plus 0, not there. Dv dx, same deal, is going to be 2 and then nothing there. We're then going to follow the rule, okay? So I have enough information here to follow my rule. Du dx ends up to be u. U is 3x cubed minus 2x squared plus 4, all being multiplied by 2, plus v times, which is 2x minus 1, times du dx, which is 9x squared minus 4x. I'm now going to multiply them. And when I multiply them, I'm going to get 2 times 3x squared, which is 6x cubed. Sorry, 2 times 2x squared, which is minus 4x squared. 4 times 2, 8. Go again, 18x cubed. 2x by minus 4x gives me minus 8x squared minus 9x squared minus 1 by minus 4x is plus 4x. Group them. X cubes, 24x cubes. X squared minus 21x squared. X's. And then finally regular numbers, and that's your answer. This is a quotient drill. Now you'll see what's very different from the product drill. It's very much every single one of these is a fraction. Now you do what you did last time. Y equals u over phi. The top one is u, the bottom one is phi. Okay? U equals 3x minus 1. Then differentiate and you get du dx equals 3. Phi is x squared minus 2. Differentiate and you get the v dx equals 2x. Just 2 multiplied by x plus nothing. Now that you have your list, okay, which is here, what you can do now is you can just go into the main equation, okay? So that's all the values you need. Now start off. The y dx is equal to phi times du dx. Phi is x squared minus 2. Du dx is 3. Minus u times the v dx, which is 3x minus 1. And then the v dx is 2x. Now, what I like to do in scenarios like this is I like to move the smaller one to the front. So I'm going to change that around to 2x bracket 3x minus 1. Is everybody happy with that? Because it's multiplied. It doesn't matter which one comes first, okay? Because it's being multiplied. Now, all over phi squared. Phi is x squared minus 2. And you're going to have to square that. Don't square out the bottom. You rarely ever have to square out the bottom of a quotient drill, so never do it. Unless, it's just the way it turns out. Just never. You'll see all the answers in the back of the book, haven't got them squared out. You'd only square it out if there was something specific you had to turn it into. And you had to square it out to get there.
I'll say that these x and minus 2.
X squared minus 2 squared.
Yeah, but what it says x minus 2.
No, it's x squared minus 2 squared. I see nothing wrong.
But it's minus.
Where you have minus 2.
Sorry guys, that's not x to the minus 2, it's actually x squared. Thank you. Okay? So, what happens next is you multiply out, you get the y dx equals 3x squared minus 6 minus 6x squared minus 2x times minus 1 is plus 2x, all divided by, and once again as I said, don't square it out. Okay, 3x squared minus 6x squared is minus 3x squared plus 2x minus 6. Okay, and on the bottom is x squared minus 2 squared. Now, there's no, just leave it as is, no point factorising or doing anything like that. Okay, so that's your answer. Do you need me to do one more? Okay. Now, number 12. Number 12, okay? U equals x squared minus x minus 6. Differentiate du dx ends up to be 2x minus 1. Because that's minus 1x. Phi equals x squared plus 1x minus 6. The v dx therefore is 2x plus 1. Insert them into the formula. The y dx ends up to be phi times du dx, which is going to be x squared plus x minus 6 into du dx, which is 2x minus 1. The next one is u times the v dx. I'm going to switch that around. I'm going to put the v dx in front. So it's going to be minus bracket 2x plus 1. and I'm going to need a lot more space. The VDX is 2x plus 1. So just give me this for a second. Okay, so it's going to be 2x plus 1 times whatever u is, times u. U is going to be x squared minus x minus 6. This is all being divided by phi squared, which is x squared plus x minus 6. It's not so much difficult as it is long. What I'm going to do next is I'm going to change this around to the opposite way around. It doesn't make a difference, it's just a preference I have. Okay, now that I've done that, okay guys, what's going to happen is I'm going to multiply it out. 2x by x squared, 2x cubed, 2x by plus x plus 2x squared, 2x by minus 6 minus 12x. Right, so it's actually going to be a lot of workings up here. After that it's going to be minus x squared minus 1x plus 6 when you multiply it out. That's all the black part there. Now the blue part I'm going to put in brackets because I don't want to make any mistakes. Minus close bracket 2x cubed minus 2x squared minus 12x plus 1x squared minus x minus 6 close bracket, all divided by x squared plus x minus 6 squared. Tidy up, very important. 2x cubed, then x squared. 2x squared minus x squared plus 1x squared. Minus 12x minus 1x minus 13x. After that, just plus 6. Inside the brackets here, tidy up. I'm going to tidy it up here, then I'm going to multiply by minus 1. So it's minus 1 times what's in here. 2x cubed remains unchanged. X squared is going to be minus x squared. Minus 1x squared. The 12x gets added to the minus x, become minus 13x, and that's minus 6. I'm now going to multiply everything in here by minus 1. I'm now going to get minus 2x cubed, plus 1x squared, plus 13x, plus 6. Let's look what happens. Cancel, 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 cancel. You're going to get 2x squared plus 12. All divided by x squared plus x minus 6 squared. Done.